Good morning. So we've all seen words in the media, buzzwords such as sustainability, carbon footprinting, and global warming. Regardless of your personal viewpoints on environmental issues, this is a topic that's very important to you as pulse growers. And this is because increasingly so, consumers have many choices when it comes to what they want to buy. There's many organizations out there vying for their consumer dollars, and increasingly so, consumers take environmental issues into consideration when making buying decisions. Because this is something that we can't ignore, the Pulse Community commissioned a 3-year study. The study looked at the environmental, social, and economic impacts of pulse crop production in Western Canada. This is a 3-year study that ended in March of last year. And what we did was we looked at 4 main scenarios, and those were pulses in rotation, pulses for swine feed, pulses for human consumption, and lastly, pulses for ethanol production. We looked at the top 2. Today I'm going to discuss the top 2 scenarios, so pulses in rotation and pulses for swine seed. And more specifically, I'm going to talk about the environmental results. So to do the environmental analysis, we used a thought process called life cycle assessment. Life cycle assessment, or LCA, is a cradle-to-grave assessment of the environmental impacts of a product, process, or system. So today I'm talking about that for pulse crops, but it can be applied to really anything. So traditionally, environmental analysis looked at the manufacturing and production of a product and then its subsequent use. Life cycle assessment is really kind of useful in that it expands the system boundaries. It can look at not only the manufacturing and use, but also the upstream material extraction and processing. If it can look then downstream at the waste management. It can also include any recycling, remanufacturing, or reuse included in the system. So again, this is what we mean by cradle-to-grave or cradle-to-gate analysis. And this is really useful in that it expands the system boundaries and allows for a more accurate apples-to-apples comparison. So again, traditionally, environmental analysis kind of focused on greenhouse gas emissions and energy use. Life cycle assessment is useful in that it can look at a whole host of environmental impacts. So I have 6 examples up here on the screen. So again, we can look at more traditional global warming and energy use, but we can also look at other ones. Some examples I have up here are nutrient runoff into lakes. We can also look at production of cancer-causing agents, land use, and mineral extraction. So why is this important to you as pulse growers? The first reason is that life cycle assessment results can be used for decision making by consumers, producers, and policymakers. The second reason is that environmental product declarations are increasing in trend. Environmental product declarations are essentially like a nutrition label, but instead of including nutrient information, they include things like the carbon content. The third reason, which is very closely tied to environmental product declarations, is potential trade and regulations that are up and coming. An example that may hit close home to you is that of soybean growers. In Europe, they have something called the Renewable Fuel Standards. And what that is that it sets a certain minimum threshold for the environmental comparison of the feedstock compared to petroleum. When they did the life cycle assessment for soybeans, it was found that that didn't meet the minimum threshold. So again, that was a market that was closed off to soybean growers. So what this example nicely shows is that LCA can be the difference between expanding your markets and closing them off. To make sure that our comparison was accurate to pulse production in Western Canada, we had a lot of checks and balances that we put in place. So we followed International Standards Organization guidelines for LCA. We also looked at over 300 journal articles that were published for results. We included analysis of raw data, and we also chatted with over 20 experts. In addition, we had an informal stakeholder review panel that we ran our decisions past. So once we came up with the life cycle assessment, We ran the results through uncertainty and sensitivity analysis as an additional level of rigor. And then we ran that report as well as the databases that we came up with past a third-party review process. So I've talked a little bit about why we did this project, why it's important to you, and a few of the methods. Now I'm going to get into the actual results. And more specifically, I'll start with a crop rotation study and what we included in that analysis. So as you see here, we started off with the production of the energy, agricultural inputs such as pesticides and fertilizers, and infrastructure that goes into growing crops. We looked at two main rotations. The first one, which I'll call the cereal oilseed rotation, had canola grown in the first year, followed by 3 years of spring wheat. We compared that to a pulse rotation, which in the third year, instead of growing spring wheat, we grew either dry pea or lentil. So you can see that there. Then when the pulses were harvested, they were transported to the grain elevator for cleaning, and we compared the two systems based on protein-corrected grain content. So as you can see here, this is a much more expanded system boundary for analysis, and it also shows that each of these different activities had various outputs that were included in the analysis, like greenhouse gas emissions, energy, other outputs. So I'd mentioned that we looked at a total of 14 impact categories, and just for ease of discussion of the results, I'm going to talk about them in three main groupings. So the first impact category grouping that I'll talk about is global warming and resource use. That includes impact categories such as energy use, global warming, and mineral extraction. And when we made the comparison between the cereal oilseed crop and the pulse-containing crop, we saw that impact categories in this grouping were reduced 17 to 25%. The next grouping I'll talk about is ecosystem quality. That includes things like nutrient runoff and land use. And again, the pulse-containing rotation reduced impacts in these categories by 1 to 24%. The last grouping I'll talk about is human health. That's things like human toxicity and respiratory effects. Again, the pulse-containing rotation reduced impacts in this category by 3 to 28%. So this is a fairly straightforward story, and that is a good news story for pulse crops in that all 14 impact categories were reduced. And this mostly comes down to the fact that pulses fix nitrogen, and then the subsequent cereal crop requires less fertilizer application and has a higher yield. Now I'll go into the second study I want to talk about today, and that's the swine feed. So again, similar to the crop rotation study, we looked at the energy, agricultural inputs, and infrastructure required to grow the grains that go into the feed. So again, we looked at two comparisons. The first one we'll call the soybean meal diet. It consisted of wheat and barley grown in Western Canada, as well as soybeans grown in the United States. We'll compare that to a diet that I'll call the dry pea diet. And in this one, we had dry pea replace some of the soybean and wheat in the more traditional feed mix. So we included dry pea at rates of 15% for the starter diet, 42.5% for the grower diet, and 30% for the finisher diet. So again, the grains were transported to the elevator for cleaning. Soybean underwent an additional step in that it was processed into soybean meal. The soybean meal and the different grains were transported to the farm for mixing of the diet together, and then that was fed to swine in a swine production facility. We made the comparison on a 110 kilogram swine. That's how we made the comparison of these two studies. So again, you can see that there's many activities included in this and many outputs from the various activities that we looked at. So like crop production, we'll look at these three main groupings of results. But unlike crop production, this story is not quite as straightforward. It's a little bit more convoluted. So the first impact category grouping that we'll look at is global warming and resource use. And again, the dry pea diet, when compared to the soybean meal diet, reduced impacts in these categories by 2 to 11%. And that's mostly because dry pea production has environmental impacts that are less than wheat. Ecosystem quality, for the most part, the impact categories did reduce when we looked at the dry pea diet, but we do have this one result that kind of sticks out, and that's a 63% increase by the dry pea diet. What that really comes down to is that was the impact category called eutrophication, which is nutrient runoff into water bodies. And the reason for this was that the manure when we made a comparison between the manure produced by the swine fed the soybean meal diet compared to the dry pea diet. Manure in the soybean meal diet had a higher nitrogen content, and when you applied that manure to the field, those crops required less fertilizer application and therefore less nitrogen production. It is of note that we didn't include emissions from manure spreading. So I think if that was included in the analysis, this would be a much tighter result. It's also important to note that although 63% sounds like a large increase, it is still quite a small number. So the last grouping that we'll look at is human health. And again, for the most part, impacts in these categories were reduced. And that's mostly because in soybean meal processing, they use something called hexane. And when it's inhaled by humans, it's quite toxic. Because dry peas aren't processed when they go into feed for swine, we avoid the use of that hexane. Okay, so I've talked a lot about how life cycle assessment has been an improvement upon the traditional environmental analysis. But it's not a perfect science. And the first and most obvious reason for that is because it's modeled results. So we use data that is measured from the field and is real data, but when we spin the results out, they are modeled results. The other reason is that some of the data that we use, there is limited data available for that. So one example is long-term studies looking at the effect of pulses on soil quality. Another example of that is the nitrogen credit accrued to pulse crops. So in the published literature, it goes from anywhere from being a really large nitrogen credit to a small nitrogen credit to even zero. How we handled that in the results or the modeling is that that changed the amount of nitrogen applied to the cereal following the pulse crop. Lastly, the results need to be kept into context. This was a study done for Western Canada as a whole. And as you all know, farming practices, soil type, emissions, all of that changes over such a large landscape. So what does this all mean for the pulse industry? The first thing is that although very specific and isolated studies have been done on the environmental effects of pulses, this is the first study that looked at the environmental sustainability of pulses as a whole. And as I mentioned, this is a good news story for pulse growers. And it can be used for marketing. As I alluded to in the beginning, there's a lot of consumers out there that this is of growing importance to them, and they use this type of information in their decision making. I'd also talked in the beginning about how life cycle assessment is being turned to for regulatory and trade implications. And we've developed a lot of databases that we're now collaborating with other agencies so that this data is included in life cycle assessment databases being developed for North America. So that really assists pulses to be included in future LCAs. I should also mention that this is kind of the first step. So this step was done for Western Canada. We completed it in March of 2011. But there's a lot of work that should be done after this. So things that I kind of thought of would be interesting is to look at different crop rotations, looking at changing the frequency of the pulse included in that rotation, different feed mixes for the swine, and then probably what I think is probably the most important is to narrow the resolution of the study. So maybe break it down by province, and then by soil zone. So I'd like to conclude by thanking the generous support of our funders, and that's Saskatchewan Pulse Growers, as well as the ABIP in Agriculture and Agri-Food Canada. And lastly, for Pulse Days, for the invitation to come speak to you all today. Thank you.